Okay, guys. Hey, so what I have today for you are two separate examples that I would like for you guys to try to emulate by the end of the day. So we're going to talk about center of gravity again, and I'm just going to give you another example of how it works right here. These are two forks with a toothpick in between them that's balanced on another toothpick. It looks weird and it looks kind of crazy. And let me see if I can give you another angle at it like that or like so. Okay. Get really close there. You can see these forks are not touching the saucer or whatever you want to call it at all. The only things that are touching are the tips of the toothpicks there. Okay, I can actually tap them around. It might fall off, but if I tap them around, there's no glue, no nothing. They can actually, okay, they can go around that center there. So how does this work? How do we do this? This is our lesson from yesterday, center of gravity, right? So again, if you didn't watch yesterday, center of gravity is the average place where all the gravitational vectors are pulling, the average place. So there's gravity pulling down on every single atom, every single piece of mass that something has. The average place is the base of support. It's the place where that gravitational pull pulls down. It pulls down everywhere, but it's the average place. And if you have something to support it underneath that center of gravity, it will stay standing. So with this can, we have a little bit of liquid in here. There's a tiny little base of support, okay? Less than a centimeter, maybe like a half a centimeter wide that it can sit on. And yeah, it looks like most of the cans over here on this side, but because we have a little bit of liquid in it, the average of all mass actually fits within this little gap. If we have too much liquid, it's going to tip over like this. It's going to fall and tip back down because the average mass is outside of that base. If we have not enough, it's going to tip over and fall over like it did yesterday on my computer. But here we go. That thing will bounce just like that. Okay, just like such, and it kind of looks fake, and it can kind of wobble around as well, but I don't want it to fall on my computer again, so there you go. Okay, so to do this, oh gosh, that's okay. Okay, so to do this demonstration right here with the forks, you take two forks that are identical forks, and you smash them together just like this, just prong to prong, push them together. Okay, kind of force them in there until it looks like such. Okay, so then you take a toothpick. What we want to do, if we look at this, when it is upright like this, parallel with the floor, its center of gravity falls outside the object, right? Because this thing is bent, gravity's pulling straight down, the center of gravity is somewhere in the middle here, right? It fits right in here between the forks. We don't have access to it. That's where the average of all the different force vectors ends up, is right here. So to access that, we take a toothpick. Let's see if it goes on here. And you want to put it through the top, whichever fork's on top, you want to put it through the top of that one and through the second notch on the other one. Let's see if I can get that close for you guys, like right there. Okay, and then if you do that, so through the top here of this one and the second one on the next one, if you do that and you kind of wiggle it in there, hold it, you should be able to hold it with your finger like such, because the center of gravity for these forks is right here where your finger is. And if you're very careful, take a toothpick, stick it in another salt shaker or something like that, or something that'll stay sturdy. And then if you carefully balance it on that toothpick, it should be able to stay. Okay, what I'd like you guys to do is try this with a family member or somebody. Take a picture of yourself. I want thumbs up, picture yourself with both of these things in the same frame if you can. If you don't have cans at home, that's fine. Just do the forks. But try to take a picture of these two things in the same frame and post it. But yeah, so again, center of gravity right here. We're accessing the center of gravity between our base of support right here. Tiny little base of support. And it seems like it's outside of both masses, but because they're connected and they're pulling down together, the average of their gravitational pull is right on the tip of that toothpick. And so we're able to set it on there, balance it, spin it around. There we go. Okay. Post a picture. Let me know how it goes. Awesome. Have a good day, guys.